Welcome to Incremental Database Development with DataClass. In this session, we're going to cover three topics: what the kinds of big problems are, what high-level solutions to those big problems are, and how DataClass helps with those solutions. What are the big problems? Well, one big problem is deployment. Database designs change over time, but existing databases have to be upgraded. We don't really have the luxury of designing a database in terms of what we'd like today and disregarding what we already have, although oftentimes we act as though we have that luxury. Another big problem is duplication. Pretty much any time you change a database's design, at least its public design, you also have to go and change your clients. And you don't really get a good indicator of where you have to make those changes, like you would if you were changing two classes where one was a client to the other. Finally, there's an issue of design. Clients couple these designs that need to change over time. How do you keep them coupled to the right design, and how do you keep them coupled to the right version of your design? First, there's that deployment issue. To the best of our knowledge, the right way to define a database is in terms of versions. So each version has a transition, and that is the steps that get you from the last version, or from nothing in the case of the very first version, to the target version. Upgrades need to go through all the intervening versions between the current version of a database instance and the target version. So for instance, if you're trying to go from version 3 to version 7 of a database, you need to go from version 3 to version 4 to version 5 to version 6 to version 7. If you do this, the cost really isn't that high. Empty databases upgrade very quickly. And maybe a full one doesn't go that fast. But you need your databases to all march to the same drummer. And if you're doing this right, you're probably only ever upgrading your biggest databases, which presumably are your production databases, one version at a time. So this is what we'd like to see. We'd like to see we have this class of databases that we've defined, and we've got an array of existing databases. And they're in different versions. So one of them has no behavior whatsoever. One of them corresponds with our version 1.0 design, and one of them corresponds with our version 1.1 design. Well, to get the version 1.1 design, it's pretty much a no-brainer. Our class should look at the database and see, oh, that's a version 1.1 database. So I'm just going to go ahead and do nothing. Going from version 1.0 to version 1.1 should have a little bit more behavior. It should look at it and say, this is version 1.0, so I only need to apply the transition to get it to version 1.1. And an empty database it should look at and say, oh, there's nothing here, so first I'm going to upgrade it to version 1.0, and then I'm going to upgrade it to version 1.1, and now I'm done. The advantage of this process is that if you take this environment and you add another database and another version, you can go through the same process again. You want to upgrade the first database, and you see it goes straight to version 1.2, because there's only one transition step. Likewise, for the second database, it only has to go through the one transition. Third database only has to go through that one transition, and the new database goes through all the steps, goes to version 1.0, then to 1.1, and 1.2. And it does this very quickly, because there are no data in it. DataClass helps with this. Part of the point of DataClass is that you feed a database definition file in, and you get .NET classes out. Eventually, you'll get Java classes too. Right now, .NET is the only platform that's supported. So you feed your DataClass definition files into the DataClass compiler, and out comes a DLL. In that DLL are .NET classes for each of your database classes, and those classes know how to build or upgrade a database the correct way. And as a bonus, they have a tamper resistance feature in there. So if you go in and you try to change the past, you're at version 1.2, and you're going to version 1.3, and for some reason someone went in and changed your definition of what version 1.0 was, the generated classes would be able to look at a database and say, this was built with a different version 1.0 than I expected, so I'm just not going to touch the database at all. And then there's the duplication problem. My findings are that the big problem is treating how we build a database as the design of that database. This is rampant in our industry, and perhaps not everyone does it, but a lot of people do it. The solution is to pull the design out, and then you end up with this other problem of duplication between your construction logic and your design. So the solution there is to let the construction logic depend on the design, basically to bind those design symbols to your construction logic. If you imagine abstractly you have some clients and they talk to the database through their idea of what the database design is, and you have some build scripts and they talk to the database through their idea of what the design is, the solution really is to have a common notion of what the database design is, from which both the client and the build scripts draw. And that's the only way that both artifacts talk with a database. DataClass also solves this problem. The DLL that it generates when you compile your DataClass source files into a database class, they contain static properties for every symbol in the database. Some of them are public, some of them are private, depending on how you choose to encapsulate, but they're all there. If you have a breaking database design change, you get a compiler error. If you mistype a database symbol, you get a compiler error. Not a runtime error, a compiler error. And a bonus here is that it makes stored procedures look like methods. So if your documentation of the design of your database contains procedures, the generated proxies for that database will actually contain .NET methods that have the exact same parameters and return values, and it all gets bound for you. So it looks like you're just calling a method, but you're actually calling a stored procedure on a foreign object. The other bonus is the proxies make your database look just like a normal object. Finally, there's the coupling problem. How do you couple your clients to the right version? You don't want to not couple your clients to the database. You want to go the opposite way. You want to couple your clients to the public design of your database, but always to the right version, the current design. What you need is metadata for each version available in whatever it is that represents your class of databases. That includes all of your past versions, your present version, and possibly a future version. You don't want to duplicate all of the design in the past versions in the present. So you need a way of defining design in terms of how you've mutated an existing design. Then you have clients have the ability to couple to a specific version. If the metadata are all there, you have clients that can say, I really only care about version 1.0 of the database and 1.1 of the database. That's what a transition test might do. If it's specifically testing how a database is built when going from version 1 to version 2, then it really is very interested in the designs of those two versions. But on the other hand, most clients, the clients that customers care about, they really only want to couple to whatever the current version of the database is. And then some clients you'll want to couple to an in-work version. You want to take the client and say, okay, I know I'm changing the design of the database in a way that impacts this client, so I'm going to actually move this client onto the in-work version so I can start testing my database design to make sure it really applies to this client before actually switching to the current version. So this is what we'd like to see. We've got these different lenses, if you will, windows into what the design of a database class is at different points in time. So version 1.0 says there's some structure, perhaps a table. And version 1.1 says maybe there are two structures. There's a table and a view that sits on top of that table. Then version 2.0 says, well, that first structure is going away in favor of these two other structures. Upgrade scripts and whatnot, they talk to specific versions, but most clients will talk to this current lens. And the current lens is kind of a window into whatever the current version is. So maybe right now it's version 1.0. But when you add version 1.1, after you've gotten it working, you point the current lens at version 1.1 and bam, all the clients are automatically updated. You get all your compiler errors, you get everything coupled correctly again immediately. And in this case, there's probably no change because structure 1 hasn't changed, hasn't been removed. But then when you have version 2.0, you switch your current lens to point at version 2.0 again. And now, all of the clients that were coupled to the current lens have a completely different window into what the design of the database actually is. What that means is that if, say, one of the clients previously was coupled to structure 1 through the current lens, which looks at version 1.1, that you'll get a compiler error, and you can fix it immediately. This is another thing that DataClass facilitates. It allows you to declare one current version. It infers what the in-work version is from whatever version comes after the current version. Clients can couple to these generated windows into database design, and if you change whatever the current version is, they all get automatically upgraded. This puts control of what the definition of the current design of the database is in the hands of the database, where it belongs. As a class of databases needs to be the thing that controls what the definition of its current design actually is. DataClass solves these three big problems. It solves how we keep things current, how we prevent duplication, and how we upgrade or build new databases. DataClass upskills developers. Doing this work is hard. It's not something that a machine can determine. DataClass is all about getting rid of the grunt work and the redundant work and the duplication that gets in the way of us doing that. So that's what DataClass is all about. Those are the benefits to you.